All right, we are getting started here with a brand new unit, and this is the first video of our new unit. We are going to be looking at how to solve inequalities in this unit, which comes after our unit on solving equations. So today is actually not going to be too bad on you all, since you already have a lot of background knowledge from our previous unit. Now let's just kind of dive right on in here. For these first three problems right here, we're just going to fill in the blank with a one of these two symbols or an equal sign. We're going to talk about these symbols today and when you use them versus when you use the equal sign from our previous unit. And we're going to be looking a little bit on the next page for how to translate our inequalities into algebra. So let's go ahead and get started here. For these three, let's see, if you've got an 8 and a -4, I think you guys obviously know that 8 is bigger than the -4. Remember this alligator symbol kind of eats the bigger number. So this one right here, we would say 8 is greater than -4. That is how that one is typed out. 8 is greater than -4. That's what that one's saying with that blue symbol. Okay, that's all we're saying there. 8 is greater than -4. Now you might remember the symbol around a number, the straight up and down line. That's absolute value. So I want to know how far away is -15 from 0, and this would actually be 15 spaces. And you guys know that that is equal to 15. 15 equals 15. Now over here, if we have a -3 and a -9, anytime it's closer to 0, you guys know here that the -3 would be bigger than the -9. So we use these symbols right here when comparing values, and we have things that could be less than, it could be greater than, things like that. That's when we use those alligator symbols. And when do you use an equal sign? Well, when things are equal. Kind of goes without saying, when things are equal. So then over here, we can say when we use these like inequality symbols, when things are not equal. So obviously if one is bigger than the other, that means they're not equal. All right, cool. So we've kind of reviewed when you might see the equal sign versus when you might see an inequality symbol. Now let's compare these two scenarios. One of them is going to be modeled with an equation, while the other one gets modeled with an inequality. All right, let's dive on into this problem about the SCA. So our Student Council Association has purchased $25 gift cards as a thank you for the teachers who helped with the dances. So if you're a teacher who helped chaperone one of the dances, it looks like they're going to try to say thank you by giving you a $25 gift card. Now the SCA spent a total of $275 on those gift cards. So we want to know how many teachers actually helped and chaperoned and got the gift cards. So again, the SCA spent $25 for a certain number of gift cards. It was $25 for each gift card. We don't know how many they got. And we know that they spent a total of $275. Now, when we divide here to see how many gift cards we got, we're going to get 11. That's 11 gift cards. And let's just double check the math in a calculator. 275, if that's how much money they spent, and they were $25 each, yep, they got 11 gift cards. So this one is an equation because we had an actual total that got spent. Now let's compare this to number 4. Aurora's family is going on vacation and they set aside $450 for the hotel room. If the hotel room costs $75 per night, how many nights can they stay? So if it's $75 per night, I'm just going to go with $75. I'm going to use an N for night. And if they set aside $450, I'm going to put the $450 over here. Now, it doesn't say that they spent $450, so I'm not going to put an equal sign right here. It just means that if they've set aside $450, that means that they can spend up to $450. Or they could spend $450 or less. So we're going to fill in with this symbol right here. And what this is now saying is that the number of nights times the $75 just has to be less than, or it could be equal to the $450 that got spent. Now I'm going to highlight right here this symbol and knowing how to use it and knowing that the line up underneath it means or equal to, that is part of what this entire unit packet is all about. So it's okay if like right there, the 75N is less than or equal to. If for whatever reason that feels a little weird, we're going to continue to explain that throughout the packet. But I want to point out that this little line means or equal to, so we could spend the entire $450 or we could spend less. So now to solve, if we want to see how many nights they can stay, let's divide it by a 75. So the 400, let me get my calculator back out. Whoops, I don't have it. Let's get that. Here we go. So the 450 that they could spend divided by the 75 looks like they could stay for 6 nights. Now, when you guys go on vacation, if you ever do that, you don't have to spend that full amount of money. You don't have to stay the full 6 nights. You could only stay 3 nights if you wanted to. You could stay 2 nights. You could not even go. You could go for no nights, and that's still less than or equal to $6. Or, sorry, to 6 nights. So the idea here, y'all, is up here, this is when we had just one answer. In equations, in our previous unit, we had just one answer. And now in this unit, we're going to have lots of possible answers. You could stay for 1 night and that would work. 2 nights, 3 nights, you could stay for 4 nights and you would not have gone over budget. You could stay for 5 nights and you don't go over budget. But the moment you try to stay for 7 nights, now you're over budget. You can't do that. So there's only one solution to an equation. I already mentioned that to you guys. And again, here we saw that x was 11. And so if I solve that and try to put that on a number line, I want you guys to think of kind of like a screenshot, taking a screenshot of a number line. So if I put the 11 here, that means this is a 12, this is a 13, and this is a 14, and so on. And that means this would be a 10, we'd have a 9, an 8, and a 7. So you're in control of building your number line. Right here, since the number I'm dealing with is an 11, I just kind of put that in the middle. And now we're saying that x would have to be 11. That's the answer. Now, for the problem about budgeting and going on vacation, when we got this answer, we said that x was less than or equal to 6. So this time I'm going to put a 6 on my number line and just build around it. That would be a 7, an 8, a 9, and a 10. Then this would be a 5, a 4, a 3, and a 2. And this time I'm saying it could be 6. You could stay for 6 nights, or you could stay for 5, 4, 3, 2. And this now shows the solution to the inequality. When we have these graphed on a number line, it shows that there's lots of possible answers. So how many solutions or answers do we really have to an inequality? We actually have an infinite amount. As long as it's less than 6, it would be acceptable for this problem. Here though, back in our equations unit, we always only had just one answer. So I know a lot of you have heard of the word infinity. And infinity is the idea that the numbers go on forever and ever and ever. And that is used with this symbol. And so if I ask how many answers there are to this, well, it could go on forever and ever and ever as long as it's less than 6. So we would say that that's an infinite number of answers, an infinite number of answers. All right, now let's flip over. We've been talking a lot lately about how to translate into our language of algebra. And here I've got kind of like a word bank to help you guys remember all of the words that might go along with a certain symbol that you see. So for example, if I put an X here and then a 2 here, I can now say X is more than 2. X is greater than 2. X is larger than 2. X is above 2. All right, let's do it with this one. If we say X has a X has a minimum of 2, that means it could be everything that's 2 or bigger. If X is at least 2, it could be 2 or more. If X is not less than 2, it's 2 or greater. And if X is not smaller than 2, this is how it looks. Now, the one that I think you guys are probably really used to here is seeing X is greater than or equal to 2. That's the basic one that was almost so basic I didn't even put it in that column. That x is greater than or equal to 2. And if x is everything that's bigger than or equal to 2, that means that 2 is a minimum. All right. For the next one, if we say x here and then put a 2, I've got x is smaller than 2, x is less than 2, x is below 2. Now, if you see it with the little line up underneath it, that means x is less than or equal to 2, meaning it could be anything that is 2 or smaller, which now means 2 is our maximum, which means x is at most a 2, x is not more than 2, and x is not greater than 2. So there are lots of like math synonyms, if you will. These are all synonyms. Sorry, I can't spell that. Don't go tell your English teachers that I was struggling to spell the word synonym in one of my videos. But yeah, these are all synonyms. So maximum, at most, not more than, is not greater than. These are all synonyms of each other. This is another list of synonyms, and so on and so forth. All right, now let's kind of practice putting this into play. So the first one we have is that a number y is less than 3. So y is less than negative 3. Done. A number z is greater than or equal to 4. So z is greater than or equal to 4. Now, on a bus, if the bus can seat at most 60 people, that means the bus can seat less than or equal to 60. It could hold a full 60, or it could hold 59 or 58. It could even hold one person. It could just be the driver on the bus, and one is less than 60, so that would work. So see how here, if it's at most, I've got the keyword up here to kind of help you see what symbols you should be using. All right, so let's try another one. You can miss no more than 3 questions in order to pass a science test. So let's say on a science test, there's 10 questions. You can miss no more than 3 of them in order to pass. Because if you miss more than 3, now you failed. If you miss 3 and get a 7 out of 10, you've passed. You could only miss 2 and pass. You could only miss 1 and pass. Or you could get 100, and of course you've passed. So you can miss no more than 3 questions in order to pass the test. So the number of questions that you can miss is not more than, so it has to be less than or equal to 3 questions. You can miss 1, 2, or 3 questions and you'll still have passed. All right, for the next one, your height needs to be at least 5 feet tall to go on a roller coaster. So let's say you're trying to go on a roller coaster. If you're 6 feet tall, you get to go. If you are 5'11", you get to go. As long as you are at least 5 feet tall. So 5 feet, you get to go. So as long as your height, h, is bigger than or equal to 5, you can go. And right here, I see the word at least. At least is right here. So I should have this symbol, my letter, then this symbol. So there's my height is greater than or equal to 5. So I'll start with that one right there. It's actually the second one, just because we just talked about it. If your height needs to be at least 5 feet tall, your height needs to be greater than or equal to 5 feet. And if the bus seats at most 60 people, it seats less than or equal to 60 people. So I've kind of highlighted and color coded the at most and the at least to help you guys remember that at most actually is less than or equal to, and at least is actually greater than or equal to. All right, now this part right here, we're going to look at it in algebra, and we're going to try to come up with a couple of different ways we can say it using the chart from above. So for example, I'm going to do 2 of them. I'm going to randomly pick. I'm going to fill in this one with you. I'll do this one, and then you're going to come up with another one on your own. And then I'll do this one with you. I'll do the middle 2. And then you'll come up with one on your own. And then you'll have to try this one, and this one, and this one all on your own. All right, now for this one. Obviously, we can look at it and see that x is less than or equal to 2. So that is an option. You could type in x is less than or equal to. But that's like such an easy basic one that I don't even want that one to be the one that we use. Let's try to find that symbol so it's the less than or equal to one. So up here, it's the last one. So let's say x has a maximum of 2. We could put that here. X has a maximum of 2. So if x has a maximum of 2, the highest it could be is 2. That means we want 2 or lower, and that's what that's saying. So I've done a couple here, and you're going to try to do one on your own over here off to the side. Now let's go below it, okay? So now here, obviously the easy one is x is less than 7. That's the easy one. That's the easy one. And even though you might have been tempted to start with the 7 and say 7 is greater than x, because that's right, you could say 7 is greater than x. That is true. If x is less than 7, 7 must be greater than x. Let's see. The only other thing I want to point out here, though, is that if the x comes second, maybe let's just think of it with the x first and let the alligator still eat the 7. And now that means we can come back up here to the chart and look right here. I already took the x is less than 7. So x is smaller than 7. Let's put that one over here. I won't make you guys come up with one on your own for that because there was only 3 options up above anyways. So this one I can also do the other one. Let's put what I say x is, we'll say x is smaller than. X is smaller than. Cool. X is smaller than 7. All right. So I actually did these 3 with you. I filled in 3 of them with y'all. Now again, I don't want to confuse you, so I'm going to delete this one. I'm going to delete this because I don't want you to think you have to have all these things listed. You really only have to have one thing in each box, okay? So now what I want you guys to do is I want you to pause the video, okay? And I want you to try to come up with something that can go in here and then another one. Now I already did one for you here, so now I want you to try one on your own here. Same thing, I want you to try both of these on your own. And when you get done with this, I actually want you to call me over and have me read what you wrote, and I'm going to check it off. And then you're going to come back and you're going to hit play and you're going to continue on with page 3. Okay? So I'm actually going to stop this video. When you get done with this, I want you to call me over and I want you to have me check off the ones that you wrote. And then you're going to come back for page 3. Okay? All right, that concludes this video. Thank you.